Welcome to The Explainer. Today, we're tackling a big one. We're talking about the one piece of tech, the single idea that basically lit the fuse for the entire AI explosion we're seeing today, and it's all about something called the transformer architecture. So, what is the secret ingredient here? You might think, oh, it's just more data, right? Or faster computers. And yeah, that stuff helps. But that's not the real story. The real game changer was a totally different way of thinking, a completely new blueprint for how machines could understand language. It literally changed everything. Okay, so to get why this was such a huge deal, you gotta understand the wall that everybody in AI had hit. For years, they were stuck on this one major problem. Think of it like a traffic jam, a massive bottleneck in how computers tried to read anything longer than a short phrase. Just imagine for a second. You're trying to read a book, but you can only see one word at a time. By the time you get to the end of a sentence or a paragraph, do you even remember how it started? That's exactly the problem these older AI models, things like LSTMs, were dealing with. They were reading everything in a straight line, one word after another. And this wasn't just a little bug, no, it was this massive, fundamental roadblock. The technical name for it is the vanishing gradient problem, but what it really means is that the model had a terrible long-term memory. It would just forget. The beginning of a long sentence would fade away by the time it got to the end. So real context, deep understanding, pretty much impossible. So here's the big switch. The old way is like people waiting in a single file line. It's slow, and the person at the back has no idea what's happening at the front. The transformer way? It's like taking a picture of the entire crowd at once. You see everyone, all their connections, all at the same time. This idea of parallel processing wasn't just faster, it completely demolished that old bottleneck. This whole revolution, it came from just one research paper, dropped in 2017. And it had this title that was so simple, so bold, it was almost arrogant, but it perfectly summed up their wild new idea. Attention is all you need. That's it. That's the title. And their whole point was, hey, what if we just get rid of all that slow, sequential, one word at a time stuff? What if we could build something even better using just this one single powerful tool? And that tool, that mechanism, is called self-attention. Here's the best way to think about it. For any given word, the model looks at every other word in the sentence, or even the whole document, and asks, which of you guys are important to me? It's how it knows that when it sees the word it, it's talking about the robot from way back in the first paragraph. It creates this amazing, invisible web of connections. Okay, so this attention thing sounds like magic, right? But how does it actually work? Let's pop the hood for a minute. The actual mechanics behind it are, believe it or not, super clever and elegant. All right, so the whole thing is basically built in two halves. You've got the encoder and the decoder. The encoder is like the reader. Its only job is to read the input text and just understand it deeply. It figures out all the relationships and context. Then it hands that rich understanding over to the decoder, which is like the writer. The decoder takes that understanding and uses it to write something new, like a translation or a response. So how does it figure out which words matter most? Well, it uses this clever system of queries, keys, and values. Think of it like this. For a word like it, that's your query. You're asking, what does it refer to? Then every other word in the text has a key, like a little name tag saying what it is. And each word also has a value, which is its actual meaning or substance. The model just zips around comparing the it query to all the keys to find the best match, say the word robot. Once it finds a strong match, it grabs that word's value, its meaning, and pulls it in. It does this for every single word, all at once. Now, this whole query key value dance happens inside something called an attention head. And you can think of an attention head as like one expert. Maybe this expert's entire job is just to figure out what pronouns refer to. That's all it does. It looks for those specific kinds of connections. But here's where it gets really powerful. A transformer doesn't just use one of these experts. It uses a whole bunch of them at the same time. This is multi-head attention. It's like having a whole room full of experts all reading the same sentence. One is a grammar expert, another is an expert on who did what to whom, a third one is looking at the overall sentiment, and they're all working in parallel, sharing their notes to build a super rich picture of what the text actually means. Okay, wait a second. If you're looking at all the words at the same time, like a big jumble, how do you know the order? I mean, dog bites man is a very different story from man bites dog, right? The order is crucial. The solution is just brilliant. It's called positional encoding. And all it is that before anything else happens, the model stamps each word with a little bit of data that acts like a GPS coordinate. It basically says, you're in position 1, you're in position 2, you're in position 3. So even though it's processing everything at once, it always knows the original order of the sentence. Simple, but genius. Okay, so you put it all together. You've got self-attention, you've got all those different expert heads, and you've got the positional encoding to keep track of the order. What happens then? Well, what happened was a complete earthquake in the world of AI. This wasn't just another small step. It was a giant leap. I mean, just look at this timeline. For decades, AI progress was fine. It was moving along. Then boom, 2017, the Transformer paper drops. And almost immediately after, you get this explosion. Models like BERT and, of course, GPT, all built on this foundation, just started demolishing every record and benchmark out there. The game had completely changed. And why did it happen so fast? It's actually pretty simple. By ditching that slow, sequential, single-file line approach, transformers were built for the modern world. They were perfect for parallel processing on GPUs. This meant you could train them on absolutely massive amounts of data, on a scale that was just a fantasy before. You could finally go big. And you can see the results of this everywhere now. It's not some abstract lab experiment anymore. It's ChatGPT. It's in Google Search, helping it understand what you really mean. It's in AI art generators like DALL-E. It's even helping solve huge scientific challenges like protein folding with AlphaFold. At the heart of all of these incredible tools is a transformer. So when you boil it all down, the legacy of the transformer is this. It gave AI a memory. It allowed machines to go from just seeing words to actually understanding context. It was a total paradigm shift, which, of course, leaves us all wondering, what's the next fundamental bottleneck? And what's the next attention is all you need paper that's going to come along and smash right through it?